I'm Sushma Tarna.
I am Rahul Bhargave.
I'm Zoe Gura.
I'm Yang Chen.
We are data science graduate students from Ustra Polytechnic Institute. Recently, we finished our GQP, that is Graduate Qualifying Project, sponsored by Sikion.
Our GQP title is Real-Time Cybersecurity Threat Detection, in which we are detecting two different types of network threats using two different algorithms.
The first project is outsider threat detection, that is DDoS threat detection using multivariate data analysis. This project is done by Rahul and Sushma.
The second one is insider threat detection using graph-based anomaly detection, which is done by I and Julie.
Welcome to Sikion. This is the second year that we at Sikion are hosting WPI GQP program. The data science program at WPI is quite extensive and it covers a wide variety of data science applications such as cyber defense. Sikion itself is a cybersecurity firm and is focused on empowering enterprise and service providers to defeat both known and new cyber attacks. Our customers expect us to stay ahead of the cyber attacker by countering all cyber threats in real time to eliminate any and all business impact from such attacks. The problem is like a game theory, and attackers are on a constant hunt to understand the defense and adjust their offense. The 4 students team this year implemented 2 such strategies using big data frameworks and real-time contemporary machine learning algorithms. I'll have the team members talk about their project in their own words, but I wanted to emphasize that the Sikion team is very thankful to the WPI team and their school members, school mentors, for another great conclusion of the GQP program. Good luck and thank you.
Hi. So let's talk about our first project, which is DDoS attack detection, that is distributed denial of service attack detection using multivariate data analysis. So usually the attackers generate traffic in such a way that the normal network traffic and the DDoS attack traffic will be quite similar except for few traffic features. So this becomes quite challenging for many intrusion detection algorithms to detect a DDoS attack. So our basic idea is that a DDoS attack traffic behaves quite differently from a normal network traffic in terms of a few traffic features. One of the examples of these traffic features can be entropy, variation and packet rate. So we make use of these traffic features along with series of equations in order to calculate something called as feature score. Feature score is nothing but a statistical measure where the change of one feature to other features is distributed, which reflects the change of the whole object. So we make use of such a feature score algorithm in order to classify between a DDoS attack traffic between a normal traffic. Then we also made sure that our implementation was quite scalable and fault tolerant.
So this feature score algorithm implementation is divided into 3 different phases. In phase 1, we learn about the environment using unsupervised learning, in which we compute the normal traffic profile using the feature score. In phase 2, which is the anomaly detection phase, we compute the captured traffic profile first using the feature score, and later on we compare it with the normal traffic profile in order to detect the DDoS attack. Now, if it is not a DDoS attack, then we simply update the normal traffic profile. But if it is a DDoS attack, then move it to the phase 3, which is the classification phase. In this phase, we learn about the traffic features in more detail and classify it further into the low-rate DDoS attack and high-rate DDoS attack. At the same time, we generate the different events and post it into the Kafka server using some useful information. This whole implementation is done in Spark Streaming and Scala. This GQP project has given us the golden opportunity to learn about the cybersecurity domain and modern data science technologies like Spark Streaming, Kafka, and Scala, which we had never used before in the WPI data science curriculum. Hence, in this semester, we had a very steep learning curve and we could see the tremendous amount of growth in our knowledge base. So you can see the GQP offered by WPI gives you the opportunity to work in the industry even before you start your full-time job and learn through the real experience. This was one of the reasons why I chose WPI's data science graduate program.
Start.
Hi, I worked on the insider threat detection project. We are using graph-based anomaly detection method to deal with insider threat. So the reason we are using graph-based method is because it has 2 advantages. First is graph-based methods are really good in detecting patterns. Another is graph-based methods can reduce false positive rates. But there is one challenge when we deal with insider threat. It's that the threat keeps on changing its behavior with respect to time. So instead of using one model, we are using an ensemble of models where we have n number of models and each give its own decision, and we have a voting mechanism through which we decide which one are performing worst and which one are performing better. So as we're dealing with streaming data, as we go on, we keep on dropping the models which don't perform well and keep on including models which is trained on new data. So in this project, we extracted the data from Elasticsearch and then converted it into a .g file, and that is how we get our graph data. And then this is how then we feed this to a graph-based algorithm.
This is Yang. Let me talk about the methodology and technologies we use in the GBAT insider threat detection project. We first divide the incoming data into many chunks. For each chunk, we build a model. And in each model, we use 3 different GBAT algorithms to detect 3 different kinds of anomaly. The GBAT MDL for modification, GBAT P for insertion, and GBAT MPS for deletion. Then we will use different models in that example to vote for each detected anomalies and decide whether that anomaly is really an anomaly. For the technology and tools, we first read the raw data from Elasticsearch, and in order to process the raw data in parallel, we use Spark. But our final goal is to do anomaly detection using the GBAT algorithm. The GBAT algorithm is written in C. So in order to let Spark to interact with the C code, we need to build a bridge. We did it into 2 ways. The first way is to use the PySpark to interact with the Spark server and use the Python C-types library to build a wrapper on the C code. In that way, the PySpark can interact with the wrapper. And the second way is use Scala to interact with the Spark server and use Java native interface to build a wrapper on the C code, because Java and Scala can work well. They're both based on JVM. So in that way, the Spark can interact with the C code. Thank you.
At Sekion, we are using machine learning algorithms to detect threats in real time. So this year we worked with WPI's data science students for the GQP project. There were 2 algorithms they worked on. One was for outside threat detection. There the primary idea was, attacks originate outside the organization. Sushma and Rahul worked on a fast and slow DDoS attack algorithm. Our red team was able to generate the fast DDoS attack, and the algorithm picked up. So kudos to Rahul and Sushma, great job on that. They implemented the code in Scala using the Spark framework. It's very important that algorithms scale. So great job on that. There was a bit of learning curve, but I think they came through and they did really good. Yang and Jui worked on the insider threat algorithm, which was based on graph theory. The primary idea was, if suppose there is a compromised credential at the organization, how that person can actually originate an attack, and our algorithm should be able to identify and pick up that attack. So part of the work that they did was modeling the user's behavior as graphical substructures to be able to identify what is the normal behavior, and then we can apply the algorithms to identify when that behavior changes subtly, which almost looks like normal behavior, but not quite, but rather it's actually an attack. The algorithm should be able to pick that up. I would like to thank both the teams. We really thank you for your due diligence and the hard work that you've put in, throughout your project tenure at Sekion.
We'd like to thank our industry mentors, Smith and Anandya, for their continuous support, guidance, and suggestions. We'd also like to thank our WPI professors, Fatima and Ben, for their valuable input. We are one happy GQP team.
Thank you.